This is the lecture number 6 of chapter 1. Now let us solve some more questions of exercise 1.2. Now consider question number 3. Find the LCM and SCF of the following integers. So again there are 3 parts and I am going to take first part, that is find LCM and SCF of 12, 15 and 21. So as we have discussed earlier in question number 2, to find SCF and LCM of two numbers, similarly here we are going to find the LCM and SCF of three numbers. So in the very similar fashion, factorization of 12, first number is 12, so factorize it. The required factorization is 2 into 2 into 3, that is 2 square into 3, or 15 equal to 3 into 5 and 21 equal to 3 into 7. So therefore SCF of these three numbers 12, 15 and 21 is the smallest power of the common factor. So these three numbers having the common factor 3, 3, 3 and 3, and they have same power 1. So the required SCF is 3, smallest common factor, and LCM of these three numbers is the greatest power of the factors involved. That is, the first factor is 2 and its greatest power is 2 square. Then 3, here power of 3 is 1, and the remaining factors are 5 and 7 as it is. So the required LCM is 420. Now question number 4. Given that SCF of 306 and 657 is 9, so find their LCM. By using property LCM into SCF equal to product of two numbers. Here SCF is given 9, SCF of two numbers is 9, so replacing SCF by 9. So LCM into 9 equal to the product of numbers, and therefore LCM equal to 306 into 657 divided by 9, that is 22,338. So the required LCM is 22,338. Now the next question number 5. Check whether 6 power n can end with the digit 0 for any natural number n. Here 6 power n means if we take some power of 6, for example 6 square, that is 36, 6 cube, that is 206, here its ones place is 6. So it is clear that if we take some power of 6, its ones place must be 6. But the question is, check whether it can be 0. So suppose that 6 power n ends with the digit 0, then it must have 5 as a factor, because we know that if the number ending with 0, then that number must be divisible by 5. So if 6 power n end with the digit 0, then it must have 5 as a factor. But we know that the only prime factors of 6 power n are 2 and 3, because if we write 6 power n as 2 into 3 power n, which can be written as 2 power n into 3 power n. So this implies that the prime factor of prime factors of 6, some power of 6 having the prime factor only 2 and 3. But we know that from the fundamental theorem of arithmetic that the prime factorization of each number is unique. Here we are getting two types of factorization. In first case there is a factor 5, and in the second case there are only factors 2 and 3. So this is the contradiction of this theorem, because every number can be factorized in a unique way. So our supposition, that is 6 power n with the digit 0, is wrong. So hence 6 power n cannot end with the digit 0. Similarly, you can check for 4 power n whether it can be end with the digit 0 or not by the same way.